Welcome to a demonstration by Roomfoss Control Systems covering key features and functions of our Schneider Okken intelligent switchboards. This system integrates power management, remote monitoring and control, and predictive maintenance-based systems to ensure an efficient, reliable switchboard. Featuring Schneider master-packed MTZs and NSX air breakers for precise control and robust protection. Being partners with Schneider allows us to produce switchboards using Schneider's okken metalwork and busbar solutions. Specifications of the board include a fault rating of 50 kA for 1 second, 4 incoming breakers onto a 1390 amp main bar system, Form 4B, Type 6 segregation with withdrawable plug-in feeders. The panel also features an IP31 ingress protection with top and bottom cable entry options. As an overview of the switchboard health, we see 3 segments divided into thermal monitoring, changeover and feeders. Each of these segments shows an overall status of any potential issues such as thermal warnings and alarms, supply failure and breaker configuration status, and feeder connection or trip status. We can also see an alarm tab at the bottom, which is displayed on every page, showing one of 400 potential alarms within this board. Once we've navigated to the thermal monitoring page, we can see an overview of the switchboard with status of each sensor. From this page, we're able to view each individual sensor in context of its group and alarm set point. We have 2 types of sensor on this board: Schneider EasyG TH110s and CL110s thermal sensors. The TH110 is an induced thermal sensor allowing for precise reading directly from the busbar itself. Once we have these installed, they gather their power from the current flowing through the busbar, removing the need for any intrusive maintenance. The other type of sensor is a CL110. These can be located in any cubicle of the board, allowing for either surface reading or ambient reading of the temperature and humidity. For example, feeders, VSDs, control sections, and many more. These contain a battery lasting up to 15 years. Scanning every 2 minutes, these sensors offer continuous monitoring for both alarms and data logging, allowing for predictive maintenance and local or remote storage of information on the environment and time-based events. Being shown on the changeover view, we have an overall line diagram of the switchboard. This includes information on the sources feeding in, the incoming breakers and the feeders located within the board. We are able to navigate to each of these devices from here by selection. Currently, we are in a stable condition, supplying each side of the board from the mains incoming supplies. We will now simulate a failed supply by switching the isolator off in the board. We see the breaker open before requesting the generator to run. Once running, the generator will become healthy and the breaker will close, supplying this side of the board with the generator. We won't go through every combination, but within our client specification for this solution, the switchboard will be supported by automatically running and switching to the generator from the mains on failure and automatically returning when the main supply becomes available again. If the generator does not start within a set period or fails during the support, then the buzz coupler can be closed manually by the remote HMI. As we said, this is one combination, but we offer a variety of different solutions using both brake and no brake changeover. A significant part of this solution revolves around remote switching of the incoming supplies. If we step back and ignore all of the automatic changeover, we're also able to manually switch between each of the supplies, including both electrical and software interlocking and conditions. We see more and more clients opting for this solution, making switching a much safer routine. As seen, we are monitoring key data from all devices, including contact wear for the master packed range. Schneider calculates contact wear percentage for master packed breakers based on the number of operations and the energy at fault interruptions, with trip units like Micrologic estimating wear. We then display this data for maintenance. In addition, we have implemented Rayleigh MID compliant CTs for potential billing scenarios. Navigating to the feeder detail page, we're shown status and measurements. For all devices we have network access to, we can provide data logging, alarm boundaries for current, and much more. Within this project, the feeders are mechanically switched, but the option for these to be either controlled remotely from the HMI or involved within load shedding is entirely possible using both hardwired signals and Schneider intelligent network-based switching coils. All this data is monitored and can be displayed in a variety of ways. Within this solution, we have locally stored the logs, alarms and events, sending out information to both BMS systems and Synapsys Energy systems. This demonstration highlights the advanced capabilities of our bespoke intelligent switchboards, integrating power management, remote monitoring, and predictive maintenance to enhance reliability and efficiency. Through thermal monitoring, automated changeover, feeder control, and comprehensive data access, our solutions ensure continuous operation, improved safety, and simplified maintenance. With real-time diagnostics and remote control functionalities, Roomfoss Control Systems provides a future-proof solution tailored to modern electrical infrastructure needs.